Now let's look at question two. Practice question two, actually. Jane lives in a dormitory that offers soft drinks and chips for sale in vending machines. Her utility function is U equals to 3SC. Okay. So her marginal utility of S is 3C. Marginal utility of C is 3S. And the price for soft drink is 0.5. And the price for chips is 0.25. Okay, so first, before getting into those questions, I would like to show you how do we do derivative. So here, marginal utility of soft drink is the change of utility per each soft drink. So in that case, here we will only view soft drink as the true variable. So here I'm using the banded version because we have two variables, S and C. Focus on the document camera. So we have two variables and S and C. So if we only use the D, we don't know which one we're deriving with. And here this banded tells you this is a partial derivative. Okay, so in that case, we hold a ceteris paribus condition, namely we consider everything else being the same, even the amount of chips, being the same. Okay, so what we have here is we only view S as the variable. 3C is a constant multiplying it. So it is like 3x. Fx equals to 3x. What is the derivative? That would be 3, right? And here, the derivative would be the constant before that, since S is only linear, right? It's only of power 1, okay? So the result is 3C. And marginal utility of chips is partial derivative of U with respect to chips. That is, in this case, we use this form. We view C as a variable, and 3S is a constant, like 3 here, multiply to it. So the derivative is 3S. So that's how we got those marginal utility. And some people get confused. It's marginal utility of S. Why is that 3C? And that's because we are deriving it. Okay, so that's the first part. And then the second part, first let me use what we do in class. Okay, so here we are to find the optimal decision of optimal purchase decision of C over S. And here the question in A is to say soft drink 4 chips. So it's actually the opposite. So we are using soft drink to substitute 4 chips. So soft drink in that narrative, soft drink is more like the independent variable. Okay, so here we have a fixed budget constraint. In question C, it said Jane has $5 per week. So that budget constraint is given, and we are to find the optimal decision of how many soft drink and chips to consume so that this consumer is at the highest utility. Okay, so then what we do is we still follow the 3 steps. Step 1, equal marginal principle. So marginal utility of whatever over the price of whatever equal to marginal utility of the other over the price of the other. Okay, then here we plug in numbers. So marginal utility of S is 3C over the price of S 0.5 equal to marginal utility of C is 3S over the price of C 0.25. So what we can do is we can cross multiply, right? So that is 3C by 0.25 equal to 3S by 0.5. So here we can do some elimination first. The 3 is the same on both sides. We can eliminate them. And here we can divide 0.25 to both sides of the equation. So it is C equal to S by 0.5 over 0.25, which is 2. So that is C equals to 2S. That is so-called the relationship between the quantity of the two goods when the consumption is optimal. Okay, so that's step 1. And step 2, don't forget the fact that this point is a tangent point. That's why we have the slope equal to each other, and eventually we develop equal marginal principle out of that. But also this tangent point is an intersection. So this point belongs to the budget constraint, right? And the indifference curve at the same time, but the indifference curve is undetermined. We are finding it out. So we're using the one that we know, which is the budget constraint. So that's PS by S plus PC by C equal to I. And here S and C are quantities. How many bottles of soft drinks, how many packs of chips. Okay, so here we had those numbers, and we are just plugging numbers. So it's 0.5 by S plus 0.25 by C equals to 5. And here we know already C equals to 2S, so we just replace that. So it's 0.5 S plus 0.25 by 2S equal to 5. And those are 0.25 by 2 is 0.5. So it's 0.5S plus 0.5S equal to 5. So that is 1S equal to 5. So we have the result of S. Okay. And because C equal to 2S, so C equal to 10. Okay, so that's the result. Now let's look at the rudimentary way to do this. Okay, so here the question asks is soft drink 4 chips. So first you need to interpret from the language which one is the x-axis. So the independent variable soft drink 4 chips, right? So the chips sounds like the dependent variable. So this graph is drawn this way, right? And if you were to go through the marginal rate of substitution, you may think, oh, marginal rate of substitution is the slope, the absolute value of the slope. And here, C is Y, S is X, and that slope will be delta Y over delta X, in this case, delta C over delta S. But then you need to memorize for those marginal rate of substitution being the quotient of marginal utilities of those two goods. But then you need to flip it. It is not marginal utility of C over S, it's instead marginal utility of S over C, right? It's flipped. So it is 3C over 3S, so that is C over S. That's the first one. And the second one is you need to figure out the slope of the budget constraint. So that's still the absolute value of the slope, which is the absolute value of delta Y over delta X. And in this case, C is Y, S is X. And we know that it is a price ratio, right? But what is this price ratio? It is also flipped. It is P, it was consider C being the top, and here it is actually the opposite, PS over PC. So that would be, in this case, delta 5 over delta 0.5, because PS is 0.5, PC is 0.25. So the result is 2. And here, the first one is slope of indifference curve. And the second one is the slope of budget constraint. And these two should equal to each other. because this is a tangent point, the slope of the line equals to the slope of the curve. So that would be C over S equal to 2 and C equals to 2S. So you see, I'm actually trying to use this to demonstrate to you this method being the same as the outcome of the equal marginal principle, but the equal marginal principle being much clearer. You don't have to memorize which one is on top, which one is in the bottom, which one is on top, which one is in the bottom for the two slopes. And here it is a very formulaic. It is the consequence marginal utility, your gain from consuming the product over the price of each unit of product. It's the same level. It's both from each product. You consume one pack of one bottle of soft drink, your utility increased this much, the price goes that, the cost is the unit price of that, right? So it's the same level. It's all about that single object that you consumed. It's the consequence, it's the cost of the consumption. That's for one good, and here is for the other. So it is more formulaic and error proof. Okay. So I strongly recommend using equal marginal principle to solve this rather than bothering with each slope and risking, confusing which one is on top, which one is in the bottom. So that's what I would recommend you to do. Thank you very much.